Functions can be evaluated algebraically and graphically. First, let's look at evaluating a function algebraically. Given the function 4x squared plus 3x minus 10, find f of 3. Before I do anything else, I want to consider whether I have been given an input or an output. I look at my two pieces of information and I see a number inside the parentheses, so I know that 3 is an input. Now that I know 3 is an input, I first rewrite my equation, but instead of x's, I am going to put parentheses. Then I take my input, which in this case is 3, and I put that inside every set of parentheses. Sweet. Now I just follow my order of operations. First, I look, no operations are happening inside parentheses, so I'm good. Next up is exponents, and I do have an exponent here. So 3 is being raised to the second power. 3 squared is 9. So I'm going to rewrite that as 4 times 9. And then I am going to rewrite the rest of my equation exactly as it was because there were no other exponents and I want to deal with one operation at a time. Next up in my order of operations is multiplication. I have two different places where multiplication is happening. The first at 4 times 9, that's 36. And then the second at 3 times 3, that's 9. Then the minus 10, I'm just going to rewrite because again, I'm only doing multiplication right now, and I'll deal with the minus 10 later. Now all that's left is addition and subtraction. So 36 plus 9 is 45, and then 45 minus 10 is 35. So our final answer is that f of 3 is equal to 35. This situation is a little different. First, let's read it. If f of x equals 20, evaluate the following function for the value of x. And then we're given the function f of x is equal to 7x plus 6. I like to grab this piece of information and rewrite it down here so that I can better see what I'm working with. Next, before I dive into any algebra, I want to consider if I've been given an input or an output. When I look at both pieces of information, I see x's in both parentheses, so I can tell that I've been given an output. The process when you've been given an output is different. So, first I take my original expression, which was 7x plus 6, and I set it equal to the output given by the problem, which in this case is 20. Now I solve for x. First, I'm going to subtract 6 from both sides to isolate the term with x, and I'm left with 7x equals 14. Then, to isolate x, I have to divide by its coefficient on both sides. So I divide both sides of this equation by 7, and I get that x equals 2. So we just looked at two different situations where we can evaluate a function algebraically. Now, let's look at how to evaluate a function graphically. To evaluate functions graphically, we want to start with the same question. Have I been given an input or an output? For my first question, I look at it and I see g of 4 equals. There is a number inside those parentheses, so I know I've been given an input. When we are dealing with graphs, the input is the x value. So you can think of this first problem as saying, if the x value is 4, what is the y value? To answer that question, I find 4 on my x-axis and I go up or down until I bump into the graph. In this case, when I go over to 4 on my x-axis, I have to go up to get to the graph, and the y value at that point is 1. So g of 4 equals 1. Last but not least, I'm going to start with that same question. Do I have an input or an output? Looking at my equation, I see that there is an x inside the parentheses, so I have been given an output. Another way I could read this is, if the y value is 0, what is the x value? To answer that question, I find where the y value is 0. So here's 0 on my y-axis, and then I go left or right until I bump into the graph. In this case, I move to the right, and I bump into the graph at 5. This tells me that if the y value is 0, the x value equals 5.